Yep. Good evening, everyone. Which one comes? Let's start off. Last class, we have finished with fluid statics and dynamics. We'll be starting off with SHM. Quite an important chapter. And if you ask me, it's a pretty deadly chapter. I won't say it is tough. It's like, a cherry on a cake. Meaning, literally, you can bring every damn chapter that you studied or you're going to study in the future into SHM. So the question would be like, we will see later on. You will do the entire another chapter ka problem. Anyway, we will just call it SHM. Something of that sort. So let's see how it goes. Others, keep your cams on. But yeah, meaning if you ask me, right, sir, teach us one chapter where we can revise mechanics. I will teach you SHM. It's a very interesting one that way. So let's start it off. So SHM simply means simple harmonic motion. Now, before directly jumping into that, we need to define few things clearly. The first one is periodic motion. Why is this? So what is periodic motion? The motion repeats itself after a certain interval of time indefinitely, meaning it's never going to stop. That's it. Straightforward definition. The motion should repeat itself after a certain time interval. This time period is called time period.
The fluids doesn't include like all those terminal velocity and stuff.
That is all properties of matter.
Acha, okay.
And we studied only the ideal fluids in that case. After SHM, we're going to do that only. So the time period is T. So we define frequency, which is F, which is 1 by time period. What is frequency? Frequency is simply number of oscillations per second. So number of times the motion repeats per second, we simply call it as frequency. So the symbol is F is 1 by T. That's it. Straightforward definition. Example, Earth going around the sun. It happens periodically. So one more example, let's say we have two walls here. And we have a ball here going with speed u. E is equal to 1 and E is equal to 1. And this distance is d. So if you look at the motion here, what happens? This will go from here, collide with the wall and bounces back and again comes back to this position and again collides and comes back. So if you see this total motion, right, the time period is 2d by u. The motion continues to repeat after every time interval of 2d by u. Similarly, so let's say we have a ball projected with speed u vertically, gravity is there and E is equal to 1. Same thing here, ball goes up, comes down, hits the ground, again bounces and comes back. So this motion keeps repeating after time of flight, which is 2u by g. Clear with this? So periodic motion is simply any motion that repeats itself. Any doubts on this page? Ali, do keep your cam on.
So basically, like the displacement, like after every time period is like 0, right?
The motion repeats itself after a certain interval of time. What do you mean by displacement in that? it should repeat. Everything that happened will happen again. That includes everything: displacement, velocity, position, anything that you think of. Meaning one oscillation to one oscillation should not be able to differentiate only. You can't tell which one is which oscillation. Clear with this? That's it. Straightforward definition. Let's see a question. Top view. We have a circular track. Radius is r. We have two balls here, A and B. They have same mass, and E is equal to 1. B is given speed 2u. This is given speed u. So what will happen? A will go like this, B will like this, they will collide, and they'll keep on colliding between them, right? This is a top view, there is no gravity. Find the time period.
The A does not have velocity, right? Initially.
B has also u velocity.
Oh.
A is having u and B is having 2u. Find the time period of this system or the time period of this motion. Four pi r by 3u. Nee, Lakshika, that is wrong. Two pi r by 3u. That's also wrong. You guys are finding something else. I don't want time interval between two collisions. I want time period. Meaning after collisions, A and B should come back to the same place. Do they collide at this place every time? It's pi r by 4. See. First thing, where will they collide? If I take time t, this is the time period between two collisions. The distance between them is 2 pi r by v relative. Which is 2 pi r by 3u. This is the time period between two collisions. Now, the first one, if you see here clearly, this is going with u, this is going with 2u. means this will cover 2/3 of the distance. This will cover 1/3 of the distance. So the first collision will occur exactly here at 120 degrees. Here. So this will be A, this will be B, this will be the first collision. And we know after the collision, the velocities will exchange. So B ka velocity will come to A and A ka velocity will come to. Now where will the second collision happen? This is the second collision. Now B is going slower. So this will travel 120 and A will travel 240. Now after this collision, A is here, B is here. Now A will get a velocity u and B will get a velocity 2u. Again, they'll come here and they will call it here now. Now something interesting happens. This is where the third collision occurs. But something happened here. This became A and this became B. And A has gained velocity 2u and B has gained velocity u. Did you observe one thing? Even though they're identical balls, A and B have interchanged places, right? This is not a periodic motion. So again, to come back to the same place, how many collisions will take? 3 more collisions, isn't it? So they will come back to their same places with the same velocities after 6 collisions. Are you getting this? After 3 collisions, A and B will exchange places at the topmost point. So that is not periodic motion. Periodic motion meaning everything should repeat the same way. They should be at the same position, with the same velocity, in the same orientation. Everything should look same. Exchange places. Therefore, after 6 collisions, the motion repeats. It will take again another 3 more collisions for A and B to exchange places. Therefore, time period will be 6 times t, which is 6 into 2 pi r by 3u. 4 pi r by u. Tick. Make sense?
So the balls are like horizontally placed, right?
Top view.
All right.
Top view, na? There's no gravity.
Yeah. So if there was gravity, we wouldn't have been able to do this, right? The angle thing.
Gravity. Gravity is there, so they will always collide. It will be little difficult actually, because they won't travel the same distances now. Acceleration we can't find.
Yeah.
We won't be able to find. Time nahi aayega. Maybe the motion is periodic, but we won't be able to figure out the time. Clear this? Now you tell me which chapter this question actually belongs to. Collisions.
Collisions.
End mein SHM will come and hijack the problem and say this is a time period. Getting this? This is what I was saying about this chapter. Let's see one more. But one thing, periodic motion ka questions are very little, in this thing, entire physics, general and physical 11th and 12th. That was a good one. That was a tricky one. It's not tough, but it is a tricky one. Most people will write the answer after 3 collisions, and that option will be there. Next one. E is equal to 1. So we have a 3-turn helix. Here we have a small bead. Released from rest. So this is a 3 turns smooth helix. Height of the helix is h. The radius of the helix is r. And this length is L. So if you leave this bead, and gravity is there. So what will happen? This bead will go round, will go here, hit the wall. E is equal to 1, so it will bounce back. Again, it will go round, and again it will come back. You're getting how is the motion? The motion will just keep repeating. Find the time period. Now, for people who don't know about the helix ka property, we did this thing in kinematics. If you have a rectangle and if you draw a diagonal and if you fold this rectangle into a cylinder, what you get is a helix, where this is your radius. This will be 2 pi r. This is for 1 ton helix. Huh? If this was some height h, this cylinder ka height will be h. So if I ask you this question, right, I'll give you this as a paragraph. I'll explain you what is a helix and I'll ask you questions like this. I can actually ask you more deadly questions on this. Find the normal reaction as function of height and time and stuff. That we'll see later on. Let's get this. How do we do this? How do we do this? First, let's convert this into a standard one. So a 3-turn helix, na? If you make this flat, now understand like this height h which you have is for 3 turns. Means each turn contributes h by 3. And this is r. That means for every 1 turn, you go a height of h by 3. You go a height of h by 3. And this distance will be 2 pi r. Then again, you go a height of h by 3. And this will be another 2 pi r. Again, you go a height of h by 3 and it will be another 2 pi r. Are you getting how it is? For every 2 pi r, you're coming down by h by 3. 2 pi r, h by 3. 2 pi r, h by 3. That means this total length is 6 pi r. And this total height is h. So indirectly what you got is an incline. The problem has become like this. We have an incline of height h. This is 6 pi r. So after coming here, this will go and hit the wall here at length L. And here you kept a bead of mass m. So this will come down here, will slide, hit the wall and come back again. This question you can do, na? So how will the block go? This will go down with g sine theta. Once the block reaches here, it will gain some speed v. So if I call this point as A, if I call this point as B, and if I call this point as C, time taken to go from A to B will be, from A to B, use the kinematics equation, S is equal to ut plus half at square. So S will be the length AB, which you can calculate. U is 0, half, acceleration is g sine theta, t1 square. So from here you get t1 ka value, root 2 AB by g sine theta. And you can also find the speed when it reaches the ground. V is equal to u plus at1. So the speed is at1. So from B to C, the time taken will be L is equal to V into T2. From here you get T2 ka value. Therefore, the time period T will be time taken T1 plus T2, and again while coming back into 2, isn't it? It will take T1 to come down, T2 to go horizontally, and again to go back, it will take another time T2 plus T1. That. So your answer is 2 times T1 plus T2.
No, we don't have
Tan-
L value, no.
L is given, na?
Oh, acha, L given. Okay. I didn't write that.
So tan theta is what? Opposite side by h by 6 pi r. From there you get theta. AB ka length will get from Pythagoras theorem. You know all the data here. Check it out. So if you make the helix into this incline, you will be done.
So, but when the speed is going down, it has like variable acceleration, right?
Oh, how much is that?
We don't know now. So, like, how are you saying it's g sine theta throughout its motion?
Okay, what it should be?
So, you only said that the normal will vary as the height. So, how do we know that?
But I'm not asking about normal here. What does normal has to do with acceleration?
There's a-
So you mean to say when the body is there, this normal reaction will change this acceleration?
One second, sir.
What is the tangential force, God? What is the force along the incline? Mg sine theta. Is there any other force? You're only interested in this force, isn't it? Mg sine theta. Why do I
Yeah.
care about the normal?
So, what I'm not understanding is like, how is it theta everywhere? Like, the same theta.
So do you agree when I make this, it will be this line?
Yeah.
So won't
Oh,
lines
okay,
make same
right, right,
theta?
right. I got it. Yeah.
Meaning on earth lines make same theta. So
Yeah.
you need to ask yourself which earth you belong to. Right? Clear with this? All got this? There. So that is one way to play around. So periodic motion will become something like, it repeats, the motion repeats and the equations will be quite normal. The second type of motion is oscillatory motion. Any doubts on this page? All clear, right? You can substitute the values. I'm not simplifying it. You can do that. Ali, can you keep your cam on? So what is this oscillatory motion? Oscillatory motion, the restoring force is always directed towards a point or towards the mean position or equilibrium position. What is the mean position or equilibrium position? Anyone remembers? Mean position or equilibrium position is the point where the net force is 0. Isn't that the meaning of equilibrium? Net force is 0. The max distance from the mean position is called amplitude. So when this body is oscillating, the maximum distance you go from the mean position is called amplitude. The symbol is A. Example. The most standard one is your simple pendulum. So if you take a simple pendulum here, so the lowest position is your mean position. And if you look at the oscillation, it doesn't stop here. It will continue to go here. So the restoring force is always, in this case, we call it restoring torque. So the restoring force is always towards the mean position. It will always try to come back to the lowest position. So when the same particle is on the right-hand side, the force is towards the mean position, meaning no matter how much you try to disturb this, it will always try to come to the lowest position. It will try to come. It might not come there, but it will try to come. So if you see, simple pendulum is actually an oscillatory motion. Later on, we will say we can use an approximation and make it SHM. Let me give you one more example. Simple pendulum is oscillatory. Another example, let's say we have a plus Q charge here and a plus Q charge here, right? And we keep a minus Q charge here. And we know the unlike charges attract. So this guy attracts by force F. This guy attracts by force F. The resultant F net is towards this way. This position is your mean, the center. Suppose the same minus charge Q goes on this side. This time the attraction is this way, the attraction is this way, but the resultant force one second. So F net will be again towards the mean position. Correct? So if you see, this minus Q charge will oscillate along the perpendicular bisector. So plus Q is fixed. This plus Q is fixed. So this minus Q charge oscillates along the perpendicular bisector, which will always try to come back to the center position. So this is also an oscillatory motion. Getting it? So the force should be always towards the mean position or equilibrium position. Making sense? Have a look at these examples. Clear, na? Palaksh, Aryan, Yasha, Rehan. Great. Next thing. Now, oscillator motions as such, we don't have questions. We actually, because the reason is we can't solve them, depends on the function. The next thing is SHM or simple harmonic motion. Now, what is this SHM? If the restoring force directed towards the mean, so the force is towards the mean position, and is proportional to the displacement from the mean position. So there's one more additional condition that it has to satisfy. So the function should be a linear function. Let me give an example. For example, if I have f is equal to minus k x cubed. So if you see, this x is your displacement on the mean position. So force is towards the mean position and it's attractive. Let's say if you have f is equal to some constant k by root over x square plus 1. Or if you have something like f is equal to minus x by root over ax square plus b. You create any function, doesn't matter. All these are examples of oscillatory. Now, if you have f is equal to minus k x power 1. This is oscillatory and SHM. Here, X is the displacement from mean. And negative indicates attraction. I hope you're getting the difference. Any force that depends as a function of X is oscillatory. In that, a special function X power 1 is SHM. So if you see in terms of Venn diagram, now, this is periodic, this is oscillatory, this is SHM. Making sense? It's like SHM is a very special case of it. Have a look at this. Next thing. Now, if you take an example for this, the best example is your spring and block. We will see more later on. So if you have a spring and hem here, let's say this is your mean position. If you displace this from the mean position by X, the force acting on the spring F is given by minus Kx bar. Isn't it? It's a linear function. The more you stretch the spring, the more force you get towards the mean position, and it is a linear function. So a spring block system is a typical this thing, SHM. Clear? Now, tell me one thing. Can we have a system where it is oscillatory but not periodic? One thing is clear. If if it is an SHM, it has to be oscillatory. If it is an oscillatory, will it need to be periodic? Let me give you an example. An oscillatory motion need not be periodic because see, look at the definition. Did I ever say the motion should repeat itself after a fixed time interval here? You can repeat, but there is no condition as such. The only condition is you need to have a restoring force towards the mean position. Then oscillatory motion need not be periodic. But if you go and read the textbooks now, they will write it is periodic only. So it is kind of little dicey. Example. And vice versa. Periodic motion need not be oscillatory. For example, this is not oscillatory motion, right? Why? There's no restoring force only now. The force comes only. Tell me here, what is the mean position here? Every position is mean position, isn't it? There's no force only there. So periodic motions need not be oscillatory. Example, let's say we have a pendulum. Let's say we have some sand or water. And let's say sand is leaking. So here what you have is a motion where something of this sort. Or you have an air resistance. You're getting it? So you have a time period here, but the time period is changing with time. As the sand is leaking more and more, your time period will change. We will see about that later on. Clear? Or you can have a pendulum with air resistance. Eventually it slows down and stops. Yeah, you can say that. But there's no guarantee every time every variable mass system will be, oscillatory and periodic. Just an example. Clear? So the Venn diagram actually becomes like this. Periodic, oscillatory will be somewhat outside, and you have somewhere SHM here. Making sense? All SHMs are oscillatory. Valid only for realistic cases. What do you mean by realistic cases?
Sir,
Physics is realistic.
No, sir. I meant air resistance a lot.
We will not do such kind of problems in 11th and 12th, but hey.
Okay.
Clear? Now, we'll see the mathematical part of this. Now, we said the force is proportional to x. The negative indicates restoring force. So, F is equal to minus kx. K is some proportionality constant. This will be ma is equal to minus kx. So, we have acceleration is equal to minus k by m into x. So, here put k by m is equal to omega square. We will see why later on. So this equation becomes a is equal to minus omega square x. So this is the first equation which you need to remember. So whenever there's an SHM, the acceleration and the displacement are related by this function. Now you can write acceleration as v dv by dx, which is minus omega square x. Now just imagine when this block is moving here, this is your mean position. Let's call this thing x is equal to 0. So if you displace this block and if you let it oscillate, x is equal to 0 is mean, the block can go to plus a and the block can go to minus a. So this block is oscillating between plus a to minus a. So these are extreme positions. Can you tell me what will be the velocity at extreme? 0. Why? If the velocity is not 0, it will continue to go further, right? So at the extreme positions, velocity has to be 0. Here A is your amplitude, the extreme positions. So when I integrate this, v dv is equal to minus omega square x dx, the limits will be velocity is 0 when x is equal to a. Be careful, don't put 0 to x because you don't know the velocity when x is 0. This is x, this is v. This turns out to be v square by 2 is equal to minus omega square x square by 2. Limits will go from x to a. We end up with v is equal to omega root over a square minus x square. This is the relation between the velocity and the position. This is your second result which you need to remember. Now, if I further integrate this, let me show you the next page. Any doubts on this page, please ask me. Someone was asking, realistic cases. Basically, in these cases, it is an energy losing cases, basically. I think that would be a better word to say than saying mass changes. So whenever the system loses energy, the time period will keep messed up. Again, not all energy losing cases, and again, will satisfy this. Generally, energy losing cases, right, the time period gets messed up. Meaning, logically, if the energy is losing, eventually you have to stop. And if you're stopping, your time period is changing. So the motion is not periodic. As simple as that. Now, coming back to this. So we have velocity v is equal to omega root over a square minus x square. This can be written as dx by dt. So dx by root over a square minus x square is omega dt. Now here we use integration by substitution. Put x is equal to a sine theta. Then we have dx is equal to a sine ka differential is cos theta d theta. Substitute a cos theta d theta by, this will be a into cos theta, is equal to omega dt. Now integrate on both sides. A cos theta cancels off. You get integral d theta is equal to omega dt. You end up with theta is equal to omega t plus some constant. If you bring that theta here from this function, this is nothing but sine inverse x by a is equal to omega t plus, let's call this phi. So phi is called phase constant. We'll talk about this phi. The phi is one of the most messed up thing. It's not difficult, but you need to know that properly what is phi, because this will come in SHM, it will come in waves, it will come in wave optics. This phi ka thing will keep popping up at 3-4 places. So understanding that phi is important. So your function becomes x is equal to sine omega t plus phi. This is your position of this particle in SHM as function of time, which is a sine function. This is the reason.
That a
sine
yeah.
omega t.
Yeah. So this function here, if you see, sine and cosine functions are called simple harmonic functions. Harmonic meaning functions which are sine and cos. Simple meaning it's a simple sine or a simple cos. Since this functions represent motion x, we call it simple harmonic motion. Did you see how we got the name? So the person whoever named it, right, he derived everything and he found out these are harmonic functions which are sine and cos, which are representing motion. So he called them simple harmonic motion. So the name came after the mathematical calculations. Simple harmonic functions. And now you'll also understand, see, why we took this k by m as omega square. If I taken suppose k by m as omega, here you would have got sine root k by m into t, it will look a little bad. But not only that, there's something more interesting. Here, if you see, the block here is going left and right, spring block. If a block is going left and right on a straight line, why the hell are you defining angular velocity and angles? You're getting it? So we need to talk about that. That was one thing which used to confuse me always. Particle is going on a line and you're saying omega and phi. Chalo, whatever symbol you want to take, why do you take omega? So that was always a confusing thing. So if you write a more generalized function here, what is x? Here x is displacement from the mean position. So you can actually generalize the function more. We can write this as x coordinate minus x mean is equal to a sine omega t plus phi. So here a is your amplitude. Omega is called angular frequency. We will talk about that also. Where omega is given by 2 pi by t or 2 pi f. And phi is a phase constant. Basically, it tells us where is the particle at t is equal to 0. Let's talk about that phi. Why did not take limits a and minus a and limits? If I take a and minus a, I will take limit 0 to 0. Then I'll get 0. You proved 0 is equal to 0. Why you want to prove 0 is equal to 0? Right? So you can prove that. Nothing like that. I'm not against zeros. You don't want to be called number racist or something like that. Everyone adjust your cams a bit. I can't see your faces, some of you. For some reason, I'm looking very black in my screen. Okay. Maybe I got painted with Muso black. Kya pata? Next thing. Clear with this? Now this function here. Remember, x is displacement. X is not x coordinate. X is a sine omega t plus phi. If I differentiate this dx by dt, you get a omega cos omega t plus phi. If I differentiate this again, dv by dt, this would be minus a omega square sine omega t plus phi. So you can clearly see here, this function a is equal to minus omega square x is coming. This can be written as d square x by dt square is equal to minus omega square x. A better way of writing this thing is, this is fine, x is displacement here. D square by dt square x minus x mean is equal to minus omega square x minus x mean. But remember, what is x mean is a constant, isn't it? Here x mean is a constant, so differentiating it won't matter. So d square x by dt square is equal to minus omega square x minus x mean. This is a differential form. And for this function, the solution is x is equal to a sine omega t plus x minus x mean a sine omega t plus phi. This is a solution for the differential equation. In Max, you have a chapter which they teach you differential equations. Now, here x can be anything. Getting it? Here x can be anything. I don't care about x actually. For example, listen, tomorrow if you get something like this, d square q by dt square is equal to minus 4 q minus 2. You can write this thing, answer q is equal to some a into sine omega will be 2t plus 5, something of that sort. So even though we proved it for displacement, mathematically, right, you can use this function for anything. So this is a solution for a differential equation. Any equation in this form can be written this way. Let me show you how it will look. Where could I do this? See. So there is a question like this, we will see later on in EMI. When we have solved this whole equation, right? Some velocity, blah, 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 it is all electrostatics. the function turned out to be like this. D square V by dt square is minus B square L square ML blah 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 into V. This is your differential equation, isn't it? So here x ka place mein what do you have? X ka place mein you have velocity. Omega ka place mein you have this curve omega square. So you can write the velocity V as V naught sine omega t plus phi. You're getting what I'm saying? It is not only for x, any kind of function, anything that you see, you can always do this. Not only this thing, you will see later on. EMI only, actually, we'll encounter this again. There, if you look at this function here, can you see this again, differential equation? D square q by dt square is minus 1 by LC cube. So we can write q is equal to q sine omega t plus phi. So you will see these kind of functions repeatedly at different places. So it is not about SHM. This is a differential equation whose solution is this. In place of q, you have x, you can use x. If it is velocity, current doesn't matter. You can be any variable because Max doesn't care what do you want to call it. It is you and I who is calling this displacement. So maybe I'll give an example here. So let's say tomorrow we get something like d square x by, this is a simple one, minus 4x minus 2. This was a mains level question or bits, I guess. So here omega square is 4. The question is find time period. That was a question. Omega is 2. Time period is 2 pi by omega. X mean is minus 2. Suppose if you have d square q by dt square is equal to minus anything omega square. Let's say we have something like q minus 3. Then you can write q minus 3 is equal to some charge q naught into sine omega t plus phi. So just remember that thing. So this is a differential equation. The solution is this. Clear so far?
So you got rid of the x mean in the left hand side because it's a constant, right?
It's a constant. If you differentiate, it will be 0 anyways.
Yeah, okay.
Clear? Now let's talk about that phi. So let's talk about that phi first mathematically, and then we will see what is the representation of it exactly. Now this phi here, it tells us, where is the particle at t is equal to 0. For example, say, there is a pendulum in a laboratory and it is oscillating. When I enter the room, the pendulum is at the mean position going this way, right? When Udayan entered the room, the pendulum is on the extreme position here. Now you tell me, when I entered the room, I saw the equation here, I will write x is equal to a sine omega t. When he entered the room, he also will write x is equal to a sine omega t. What is it, right? How do I take this into account that I and Udayan have seen the pendulum at different positions? See, time taken from here to here, time taken from here to here is same, agreed? It doesn't matter where the motion you see from, the time period to come back to the same position is same. But the thing is, he saw the motion when it is at the extreme. I saw the motion when it is at the mean position. So when you're writing that equation, how does the other person know at what time did you start watching the motion? Isn't that important? You're getting it? If there is a thesis, if I'm writing something, let me ask you a question like this. Let's say, find the time taken for the pendulum to reach the mean position. What will be the answer? It depends. What if it is starting from here? What if it is already at mean position? What if it is somewhere in the middle? Won't you get different answers for that question? So to take care of that factor, when did you start observing the motion? I'm not saying when the motion started. The pendulum is already oscillating. When did you start your clock? So for that, so we take different cases. Let's say if the pendulum, this block or pendulum, whatever, is at here, x is equal to 0 at time 0, and it is starting this way. So from the equation, x is equal to a sine omega t plus phi. When time is 0, x is 0. So this is a, this is sine phi. So we get sine phi is 0. So therefore, phi is either 0 or pi. So if you're starting at the mean position and if you're going to the right, the phi ka value should be taken as 0. Suppose if you're at x is equal to 0 and if you're going to the left, then you should write your equation with phi is equal to pi. Are you getting the meaning of this? That means if I entered the room and if I say the pendulum going to the right, I will write the equation as a sine omega t. But when you entered the room, the pendulum is going back, you will write the equation a sine omega t plus pi. I'll give you a better reason how to remember this, but for now, just try to see it mathematically. Let me take one more example. Let's say the pendulum is on this position, t is equal to 0. So when the pendulum is at the extreme, you enter the room and you started your clock. So for this equation, a sine omega t plus phi, x is a, sine omega t is 1, so this is sine phi. So we get phi is equal to 90. That means this person will write the equation as x is equal to a sine omega t plus 90. Or you can write it as a cos omega t. You're getting? So that phi tells you where is the particle starting its position from. The same way, if the particle is starting here at x is equal to minus a at t0, you end up with minus a is equal to a sine omega t plus phi. We get sine phi is equal to minus 1. Remember, phi ka value should be always between 0 to 2 pi. So it is 3 pi by 2. Making sense? So it's come back to 0 again, it is 2 pi. Now from this sequence, right, you can see there's a sequence that is happening here. Let me give you one more example. What if the particle is somewhere here, x is equal to a by 2, at t is equal to 0. Let me do it in the next page. But have a look at this page. I'm just using max here, nothing else. If I put t0, if I put x ka value, I need to get phi ka value. And remember, phi lies always between 2 pi to 0. And we'll see why that also. The guy, whoever, got all these equations right, first he did it all with variables and he started finding a similarity with something. And that is the reason you will see that omega and phi, meaning just logically so now. This guy is going left and right on a line, and here, hell, you're defining angles for them. Is something not weird? You're defining angular velocities, you're defining angles, kuch to gadbad hai. Matlab, something else is there. You're not studying actually the particle on a line, you're studying something else. So let me take you one more example here. X is equal to 0, and let's say at x is equal to a by 2. At t0, you are here. Now what is the function? X is equal to a sine omega t plus phi. So we can put a by 2 is equal to a sine phi. So we get sine phi is equal to half. That means phi can be pi by 6 or 5 pi by 6. There are two possibilities. That means you simply told me where you are. You didn't tell me which way you are going. So if you are going to the left, this phase angle is pi by 6. Now, if you think about it logically, when you are here, you said this phi is 0. When you are here, you said phi is 90. Means you'll get 30 degrees when you're going from 0 to 90, right? The same thing, if you're coming back at x is equal to a by 2, now this guy is 5 pi by 6. So the velocity will tell you the angles. So there are two things you need, the direction and the position. If you look at the same reason here, this is phi 0. You went to 90 and you came back to pi again. So the motion is like 0, 90, 180, and 150 is in the middle. Now this thing starts looking like something like a circle, isn't it? What you can see is 0, 90, 180, 270, 360. You're getting how to get the angles? So depending on which way you're going, you can get pi by 6 or 5 pi by 6. So what is this exactly? What is happening here? What are these angles? So this is how the motion is. This is how the motion is. 5 pi by 6. It's already gone from 0 to 90, and 90 say it is going towards 180, so you got 150 in the middle. So the whole idea of this thing is the guy, whoever created all this stuff, he figured out this is actually a circular motion. Consider a particle going in a circle of radius a with angular velocity omega. Right? Clockwise. We will take it as clockwise. If you will observe something here, say. So if you take this particle here, take this as x-axis, take this as y-axis. So consider a particle here of radius a and let this angle be phi here at t is equal to 0. After time t, and remember this whole setup is rotating with omega. This particle here is rotating with omega. So after time t, this guy will cover an angle of omega t plus phi. Initially already angle at phi, and it will cover extra omega t. And this is where the particle is. Now for this particle, if you drop a shadow, the foot of the perpendicular, this length, that is omega t plus phi. So this is also omega t plus phi. This length will be a sine omega t plus phi. And if you look at the time period for one revolution, it's 2 pi by angular velocity. That's the relation between omega and t. So what we are observing is, when a particle is going on a circle, what you're actually studying is this. A particle is going on a circle, but you're not studying the particle going on a circle. You're studying its shadow. So at this point, right, when you're at this point, angle phi is 0. So if the particle is here, where is the shadow? Here. When the angle covers 30 degrees, where is the shadow? Here. And if this is A and this is 30, what is this length? A by 2, na? When the particle is here, what is the angle? 90 at the extreme position. When the particle is here, where is the shadow again? Here. You're getting particle is going this way and the shadow is going to the left. When the particle is here, angle is pi, the shadow is here going back this. So what you're studying is, as the particle is going in a circle, the shadow is going on a line. So that omega and the angle phi do not belong to the shadow. They belong to the particle going in a circle. Is that making sense? So when you're writing this equation, x is equal to a sine omega t plus phi, this omega, this angle, this a are of the particle who is going in a circle. And this x is the x coordinate of that particle, or you can say the shadow of that particle. Are you getting what you're studying? That is the reason for a line you started getting angles. Or else why will a line have angular velocity and angles? So what you're studying is not the particle on a line. What you're studying is the shadow of the particle, which is going in a circle. And that is the reason you're getting all these angles and stuff. Let me show you how it looks.
A very interesting point about a simple harmonic motion is that it can be considered as a projection of a uniform.
Can you see side view? It's actually going in a circle. The side view would look like going up and down in a line.
That is, a uniform circular motion, when viewed sideways,
It actually starts
is
becoming like a
simple harmonic
line.
motion. We can also consider a simple harmonic motion to be a shadow of a uniform circular motion.
There you can see the shadow there on the right hand side. That is a projection, same thing.
Let us say that the angular speed of a particle moving along a circular path of radius a is equal to omega. If the particle starts from this position, then after time t, its angular
Current angle
displacement
omega t.
as omega,
And the
is a
vertical
measure
height
of
will be x, which is sine omega
this
t.
position into
Suppose if you start from an angle phi, this is what I showed you. Then that position will
Sine
be
of
a
this
sine
angle.
omega t plus phi.
that is omega t plus phi. This angle represents the phase constant of a simple harmonic motion. When we say that two simple harmonic motions have a phase difference of phi, this means that their corresponding circular motions,
Both of them are started at different angles on the circle.
as shown, starts from, that is, if this SHM,
Is that making sense? You're getting the shadow thing? Now it makes sense why, a straight line had omega and angle. That was the biggest confusion I always had. First they derived all the equations and they thought about the circle later on. Think now, so the guy whoever solved it, why will he use the symbols omega and phi? He will use some constants k, b, l and all that stuff, right? And then after noticing it keenly, must have observed, yeah, this thing is looking like a circle. Then you started changing the variables to get omega. Is this clear, everyone? Why we are getting the shadow there? So the heat transfer test is extended till Saturday night, because the other batch heat transfer just finished in the last class, so they need a little more time. So you guys have an advantage. You guys will have a fluid mechanics test later on. I'll make your test little separate. Where are you, SHM? There. So here what you're studying is the particle is going in a line. So if this is the particle ka position 1, this particle ka shadow is here. If this was the position of the particle 2, this was the shadow of the particle 2. So the actual motion belongs to a particle who is going in a circle. But what you're studying is the shadow. So we observed as the particle goes in a circle, the projection on x and y axis, both of them, it's in a circle. Actually, you can make it even more better. The projection on any diameter oscillates in SHM. If you take x-axis, you'll get a sine omega t plus phi. If you take y-axis, you get a cos omega t plus phi. Now that angles will make more sense to you. Clear with this? Now let me show you an example. Example, if someone says like this, the particle is here at x is equal to a by root 2. And if I say it is going this way, and if I ask you to find the phase angle, there are two ways you can do. One, mathematically, x is equal to a sine omega t plus phi. So x is a by root 2. This is a, this is sine phi. And you can say phi is pi by 4 or 135. Now, but you know the logic here that this angle will be 0 this angle will be 90, and you're still going from 0 to 90, therefore phi has to be pi by 4. That's the normal logic there. But if you draw a circle, sometimes, right, it is not so clear, you get confused. The circle will give you an answer much better, gives you more clarity. So you're saying the shadow is here, which is a by root 2. So the particle has to lie either at point 1 or the particle has to lie at point 2. Make sense? But at point 2, the particle will go this way. That means the shadow should go this way. At point 1, the particle will go this way. So the shadow will go this way. So where is this point, 1 or 2? The point is 1. That means I need to study this point here. If this is a by root 2 and this is a, this angle is 45 degrees. If that is 45, this is also 45 degrees. Therefore, phi is 45 degrees. Making sense? So if you ask me, right, the best way to remember, this is how I remember. I start like this, phi 0. Assume it is like a circle here. 0, 90. If you come back, 180. If you go here, 270, 360. Just treat the line like a circle. It will make your life more easy. Clear with this? So let's see a question. So I'll give you some positions. You tell me the phase angle. What was the last question? Number 2, right? X is equal to 0. The block is at x is equal to root 3a by 2 coming back. Find phi. Minus a by root 2 coming this way. Get me the phase angles for all these three. Okay, one is 60, 60 नहीं होगा रे. देखो ना. You are coming back. So 0, 90, you already crossed 90 na. You already crossed 90. Try. I'll give you a minute and then I'll show you. Finding phase angles is very important. You should be quite comfortable with the phase angles. See. One, you can do with the circle thing. I'll show you both the ways. First, let me show it normally. So draw a circle. You said root 3a by 2, meaning shadow is here. Itna to pata hai. Now you need to check only once. Is it the upper one or is it the lower one? The lower one will go this way, upper one will go this way. That means if you take the lower one, the velocity would be backward, and that is what is given. So that means you're talking about 0.2. Make sense? That is how you figure out whether the point is up or down. So from here to here, it is a. Remember, the phase angle is this. If that is root 3a by 2, this angle here will be how much? Sine cos theta root 3 by 2, that is 30. cos 30, that is 60 degrees, and that is 90. So phi would be 90 plus 60. Yeah, I messed up something. Cos 30, that is 30 degrees actually.
120.
Yeah, that is 30 degrees. This would be 30 degrees. Therefore, phi would be 120. This is how you do normally. But let me give you a better way and a faster way. See, listen. Just let me ask you this thing. Forget about plus, minus, left, right, sub chhod do. When you see a by root 2, what do you see? 45 degrees. That much you should know. 1 by root 2 is 45 degrees. Fair enough. Now, if you look at this motion here, meaning from here to here, it is going here. How much is this? 90. Then you're coming back again. So if you look at, mark all the angles, you can see phi is 0. You went till here. Phi is 90. Then you took a turn and came back here. Then phi is 180. Now from 0 to 1 by root 2, you traveled another 45 degrees. So from here to here, it is 45 degrees. That means you have reached a point here where the phase angle is pi plus pi by 4. Oh, but it is coming back now, sorry. Means you continue further, go to the left extreme, phi is 3 pi by 2. Then you took a turn here. How much did you travel? 45. This is also 45. So you can say two ways actually. Phi is 2 pi minus 45, which is 7 pi by 4. Or you can say phi is 3 pi by 2 plus pi by 4. Doesn't matter, same answer. You getting how I'm doing? You first check what is 1 by root 2, 45 degrees from the mean position. What is a by 2? A by 2 is 30 degrees from mean position. Right or left, you will see later on. Now you have to travel from here to here, 180 degrees plus 30. 210, na? Pi plus pi by 6. So phi would be 7 pi by 6. Is that making sense, everyone? There is no need to draw circle, all that nonsense. Kuch zarurat nahi hai. Just see the number and finish it off. Let me give you one more. You tell me by seeing the answer. Suppose x is 0 is this. Let's say this is x is equal to minus root 3a by 2 going this way. The moment you see root 3a by 2, just remember 60 degrees from mean. Left or right is different. Meaning from the mean position, you're 60 degrees away. Then count 0, 90, 180, or you can simply say 360 minus 60, na? This angle is 60 degrees. So phi is simply 360 minus 60. 300 degrees, or 5 pi by 3. Or 3 pi by 2 plus pi by 6. Is this making sense? There's no need to draw circle, nothing. You just see and finish it off. What about this guy? X is equal to, I've given everything, I guess. Same thing. Root 3a by 2 going this way. Now, so you just need to check what is 1 by 2, 30 degrees. 1 by root 2, 45 degrees. Root 3 by 2, 60 degrees. Ye to common hai. Then you just imagine your circle and you see where you are on the circle and finish it off. So this distance is 60 degrees. From here to here is 180 degrees. So phi is 240 degrees or 4 pi by 3. Is this making sense? Anyone not convinced with this, please ask. Very important find. Not only for this chapter. बाद में waves आएगा. it should be obvious how to find phi. All clear with this? Take a break. Come back by 70. We'll continue from here. Any doubts so far? Please ask me. Anyone not convinced with the phi? Chalo, take a break and come back in 10 minutes then. Chalo, camps on everyone. Let's start off.
Sir,
हाँ,
can you explain the C part again?
क्या हुआ सी पार्ट का?
So,
180 plus 60, 180 plus 30, 210.
अच्छा, okay, got it.
वो तो ऐसा जा रहा है ना रिकॉर्ड. सर्किल कहाँ पे कंप्लीट होगा?
हाँ,
सेमी सर्किल प्लस समथिंग ना.
yeah,
ऐसा सोचो ना, लाइन छोड़ दो, अभी सर्किल जैसा सोचो इसको. Next thing, so if you try to draw the graphs in SHM, right? A is equal to minus omega square x. So if you plot an AX graph, it's a line passing through the origin. This is theta, slope. Tan theta is minus omega square. It's a straight line. If you take velocity, which is omega root over a square minus x square, V max is a omega. This occurs at mean position when x is 0. This is at extreme position when x is equal to a. So here we can simplify this. V square by omega square is equal to a square minus x square. This is v square by a square omega square plus x square by a square is equal to 1. What is this? This is an ellipse. So a Vx graph is an ellipse. Other scan form, where this peak value is a omega, this peak value is minus a omega, this is a, and this is minus a. Clear? Have a look at these graphs. Next thing. If you try to plot a graph between A and V, we know V is equal to omega root over A square minus X square. So I can write this thing as V square, omega square, A square minus omega square X square. So we can write this thing as omega square A square minus omega square. What is X? A square by omega power 4. A is minus omega square X, and I substituted there. This will be V square by omega square A square plus A square omega power 4 A square is equal to 1. So this is also an ellipse. It's a non-standard graph. Generally, they don't touch this, but if at all they ask you the shape, at least that is important. And we know X is equal to A sine omega t. Consider phi is equal to 0. If phi is equal to 0, position time graph, velocity time graph, acceleration time graph. An xt graph will be a sine graph. Vt graph will be a cos graph. This will be a minus sine graph. Check it out. Can you go back the graphs here? Yeah. Phasor is a representation of SHMS circular motion. Okay, great. You know the definition. So what will you do with that? What that has to do with what I'm teaching you right now? Clear with this? We'll see what is the phasor. Don't worry. Let me teach you. I know, I asked, but you said something else. After full one rotation and all, I said, why? Let's see a question. X is equal to 10 cos square pi by 3t plus pi by 6. This x is x coordinate here. This is not the displacement. This is x coordinate. Simple question will be find amplitude. That would be a proper neat level question. V max, acceleration max, x mean, time period. Time taken for it to come to rest for the first time. That time taken will be the proper mains level question. We'll see this. How do we do this? I'll just give you one advice. Remember, your general equation is what? X minus x mean is a sine omega t plus phi. So somehow using your great mathematical skills, you have to convert this guy into this form and then compare. If you understood this, physics part is done. Now how to do from there to here is your max. Since all of your max pros, you can do this. I'm weak in max, so it is fine. How do we do this? Take a minute. Convert that cos square into sine power 1. There, let me help you out. So x is equal to 10, and if you remember, I told you this. When did I tell you this? Not even this. Basic maths and vectors. Let's see. Second page. Can you see something here? This was the first day class, second page. I told you something. The red box. And I told you this will keep coming up multiple places. So 10, what is cos square? 1 plus cos 2 theta. Okay. Pi by 3, pi by 2, plus x by 2. This will be x minus 5 is equal to 5, but you want sine. So sine 90 plus 2 pi by 3t plus pi by 3. So x minus 5 is equal to 5 sine 2 pi by 3t plus 90 plus 60 pi by 6. Now compare this with x is equal to x mean, amplitude, sine omega t plus 5. You got everything. You got amplitude. You got omega. And then from there you'll get Vmax. Vmax is A omega. You get A max, which is A omega square. We got x mean, which is 5. We got phase angle, which is 5 pi by 6. I didn't ask you that. I should have asked you. That's a very important thing. Time period is 2 pi by omega. Can you find the time when it comes to rest? That's how you convert something into a power 1. Don't forget that. Again, this will repeat in 2 more chapters, waves and AC circuits. Find the time taken for the particle to come to at rest. Initially, the particle is not at rest. It is at 5 pi by 6. Means you started your clock at some random time in the middle. See, where are you initially? What is your phase angle? 5 pi by 6, right? Let's go back to the circle. You're confused. That's the best thing to do. Circle, or you can even do it normally. You see whichever you like. If I do it normally, I'll show you like this. Means at t0, you're here at 5 pi by 6. Basically, it's a circle only. I'll just draw a circle better. So from here, somewhere here, so this angle is 150 degrees. That means the particle is here. Now you tell me, when will the shadow come to rest? It's traveling this way. It comes to rest here, na? At the extreme position. Agreed? That means how much is this angle? That is 90 plus 30, 120 degrees. Agreed? So the particle has to travel 120 degrees before it comes to rest. 120 degrees is 2 pi by 3. So for this guy to go from here to here, so time taken for it to come to rest is 2 pi by 3 angle by omega, which is 2 pi by 3 omega. That's your answer. That's it. The question is, when will it come to rest? Indirectly is asking you, when will it reach the extreme position? Is that making sense? And if you're starting at 5 pi by 6, the next extreme position will come at 3 pi by 2, 270. The two extremes are where? One is at 90, one is at 270. Is that making sense, everyone? So if I try to draw it on a line, x is equal to 0, you're at rest. You're at rest here. And you're starting somewhere here. You're going back here, and this phase angle is 5 pi by 6. Means you have already gone front and you have come till here. So for you to come to rest, you need to reach this guy. So this angle is already 30 degrees. This angle will be another 90 degrees. So you're traveling 120 degrees. Is this making sense? Always see in terms of circles. Don't forget about the line. Getting it? Particle covers 120 degrees till it reaches the left extreme. And we know from circular motion, theta is equal to omega into time. This is kind of like s is equal to ut, constant acceleration. So time is equal to theta by omega. So theta is 2 pi by 3 omega. Yeah, are you getting this? You just make it a circular motion question. It will be quite easy to find times. So when you see this system, forget about the line and just think about the particle going in a circle, and what you're studying is a shadow. Now the line will start looking like a circle for you. Easy? Making sense?
So otherwise, you can directly substitute the x coordinate also. Right?
What will you do with x coordinate?
So we know that x mean is phi and amplitude is phi, so we can make plus minus
So
pi. So
no,
like if
what will you substitute x as? Tell me that.
like 10 or 0, no? Depending on
There is a problem. There's a problem there. If you put 10 or 0, you'll get a cos ka function.
yeah.
So you mean to say, suppose if I got sine theta is equal to half, does this mean it's only 30 degrees?
Oh,
There are multiple values, right? Which one will you take? And the question is the first time.
right. Got it.
You will see something like that also. Now, if you look at the whole motion, right, you know, how is this guy looking like? Just think of a spring and block. X is equal to 5 is your mean position. X is equal to 10 is extreme position. X is equal to 0 is another extreme position. Every time you need not start from origin. And this distance is your amplitude. Are you getting the system? This question ka diagram is this. A spring block system which is oscillating from 0 to plus 10. And the mean position at x is equal to 5. Are you clear? What did we study? This equation represents this motion. All got this? Great. Let me see one more in a different way. So I gave you an equation and I'm asking you data. Now we will do the other way around. I'll give you data and I want an equation. A particle crosses mean position 100 times per second. Vmax is 10 meter per second. X mean is minus 3 meters. At t is equal to 0, particle is at half of the amplitude and going towards the mean. And going towards negative extreme. Or left extreme. Find equation of the SHM. What is the equation of SHM? X minus x mean is equal to a sine omega t plus phi. So indirectly, what I'm asking you is to fill up the, find me the values of x mean, a, omega, and phi, and your job's done. Let's get this. This time I give you the information and I want the equation. How do we approach this? Let's see. First thing, what is omega? What is frequency? That's our biggest trap. In one oscillation, how many times you cross the mean position? In one oscillation, particle crosses the mean position twice. And you're crossing 100 times per second. Therefore, frequency is 50. Are you getting this? If you're taken f as 100, you're gone. The whole question is gone. Therefore, omega is 2 pi f. That is 100 pi. Clear? So what you get is frequency. Number of oscillations per second is frequency. That is f. Omega is angular frequency. Don't get confused between both the words. Omega is literally the angular velocity. I got omega. What is Vmax? A omega. I know omega from here. Vmax is 10. A and omega is 100 pi. I got the amplitude from here. A is 1 by 10 pi. X mean is given, -3. I need to find phi. Now the problem here is information is insufficient. You said you're at half of the amplitude. Means you can be at a by 2 or you can be at minus a by 2. And you can still be going on both the sides, isn't it? Now you didn't tell me which one it is. So there are two possible answers. If it's a multiple choice question, you have to mark both of them. So for this guy, starting here and coming this phase angle will be 5 pi by 6. Because half is 30 degrees. Whereas minus a by 2, this is 180 plus 30, 7 pi by 6. So there are two possible answers. I have all the information. You can dump it in the equation and get the answer. Please check. The main part is the frequency. That's where most people goof up. They see 100 times and they think f is 100. Unfortunately, the answer will be there. Check it out. Next thing. Any doubts on this? Clear, na? Malika, Partika, got this? Palaksh, Lakshika, Adrit, Ali, got this? Perfect. Next one. This is also an important one, right? Whatever I'm teaching you now, right? We will see similar questions in waves and again alternating LC oscillations, circuits basically. A particle is an SHM. With time period t. Find the time taken to go from x is equal to 0 to x is equal to a by 2. X is equal to 0. X is equal to minus a by 2 to x is equal to root 3 a by 2. X is equal to a by root 2 to x is equal to minus a. X is equal to a by 2 to x is equal to minus root 3 a by 2. Yeah, let's get them out. So particle is oscillating in SHM with time period t. So answer will come in terms of t. From 0 to a, what is our time? Minus a by 2 to root 3 a by 2, a by root 2 to minus a by 2 to minus root 3 by 2. Think for a minute, then I'll show you something. Then I'll give you another 1 or 2 minutes. Yeah, you need to give all possible answers. Matlab, directly, indirectly. Right, Utsa. That while returning, returning nahi hoga na. Once you crossed, you crossed already. You could be going like this, na, 0 to a by 2. Listen to this thing. You need to remember this results, huh? Let's say I will take from here x is equal to 0 to x is equal to a, x is equal to a by 2, x is equal to a by root 2, x is equal to root 3a by 2. You can actually calculate it easily. X is equal to a sine omega t. If you put a by 2 here, you get a sine omega t. We will take the smallest possible value. Omega t is pi by 6. Therefore, t will be 2 pi by omega na t by 12. Like this, you can find for each value. So from 0 to a by 2, the time is t by 12. From 0 to a by root 2, time is t by 8. From 0 to root 3 a by 2, time is t by 6. From 0 to a, time is t by 4. Vice versa, if you try to go in the reverse, that means from here to here, obviously the remaining time, t by 4 minus this, is t by 6, t by 8, t by 12. Check it out. So if you remember these values from 0 to a by 2, 0 to a by root 2, 0 to root 3 a by 2, you can finish all the answers. You'll get it quite fast. Have a look at this. Yeah, right, Palav. You should remember these values. It will save you a lot of time in the exam. Now see, what is the first one? 0 to a by 2. Now the problem here is I didn't give you properly. One, you could have gone directly. In that case, the answer is t by 12 and you're done. Second possibility, it could have gone backward. Then it could have gone like this. Then it could have gone like this. So this will be t by 4, t by 4, and t by 12. So the second answer is t by 2 plus t by 12. That is 7t by 12. I didn't say how you are traveling. But in the question, if they mention, find the time to go from 0 to a by 2 directly, then it is t by 12, the shortest time. And someone, if you don't think like this, this is not acceptable answer. The moment you touch a by 2, question is over. There is nothing like going and coming back. Are you getting this? So that way, for every question, you'll have two options. So for the B part, you're traveling from x is equal to minus a by 2 to root 3 a by 2. So if you go directly, a by 2 to 0 is how much? T by 12. 0 to root 3 a by 2 is t by 6. So that is answer is t by 4. T by 2 क्या? 2, 3, t by 4. Or you can go back, then come front and then go like this. This is another way. This is t by 6, t by 4 and t by 6. That will be t by 3 plus t by 4. 7 t by 12 again. T by 3 plus t by, yeah. Is this clear, everyone? Getting how we're doing? Can you do for C and D? Finish it off. So this is what I was saying. If you remember this results for each section, you can just add it up. There's no need to struggle and solve. Or you can go back to the circle method. Look at the 2 points, find the angle between them and finish it off 2 pi by omega. Anyone not convinced with this, please ask me. I hope everyone is getting this thing right. The equation, but this, if you see, it's all mostly mathematical. There's very less physics in this. Clear? What about the third answer? You're traveling from A by root 2 to minus A. You could have gone directly here, t by 8 and t by 4, or you could have gone back, t by 8, you could have come front, t by 4, and then you could have come front, t by 4. T by 12, t by 6, I think it's the same question as first one. Yeah, B and D are same, I guess. Yeah. Or you could have gone back, come front and come front. B and D are same actually. I just reversed the signs. Is this clear, everyone? So if you remember this, it is easy to find out. In case you forgot also, logically सोचो ना, ज़्यादा कुछ नहीं है. Let's say you forgot root 3 by 2 का value. Root 3 by 2 is equal to sine omega t. That means omega t is pi by 3. Omega is 2 pi by capital T is pi by 3. So t will be t by 6. You just substitute, you get the value. It's not that difficult also to find the value in case you forgot. Just substitute that x value in a sine omega t and get small t from there. Easy? Anyone not clear with this? Next one. Turn the page. Clear na, Arjun? Aryan?
Yes, sir.
Neil? Yasha? Vidyut? Great. We have two particles in SHM. X1 is a sine omega t. X2 is a sine omega t plus pi by 3. So two particles oscillate along the same line. With same mean position. Assume they do not collide, okay? They're like just shadows. Find the time when they meet. and maximum distance between them. Think about it logically, right? Can both of them go to the extreme position at the same time? If both of them go to the extremes at same time, phase angle kitna hona chahiye? This is 90, this is 270, 180 degrees na? But this is only 60. So that means as one is traveling, one is chasing, when this is turning, this is chasing. So there's a maximum distance between them. Get them? It's a good question. Especially the second one is a pretty good one, maximum distance between them. How do we do this?
So time in terms of omega.
Yeah, you can give in terms of omega.
Okay.
Let's see, I don't know the answer. T/6. नहीं रे Lakshika, T/6 कैसा होगा? Means you are assuming the time taken when x1 goes from 0 to pi/3, the x2 will be sitting there and waiting for you. How to do? Maybe you're right. Let's see. Maybe you got the answer. T/6. Okay. So go back when they meet. Fair enough. But let's see how to do this thing. You can use a circle and do, but sometimes that can be confusing. So we'll go back to the basic crude max method. When they meet, what is the x coordinates? It'll be same, isn't it? When they meet, x1 is equal to x2. So a sine omega t is equal to a sine omega t plus pi/6. Till here it is great. This is where you guys go for facts. So what is omega t? Omega t is n pi plus minus 1 whole power n omega t plus pi/6. Isn't this how you write? Sine theta is equal to sine alpha. Theta is equal to n pi plus minus 1 whole power alpha. You don't write theta is equal to alpha because you can have multiple values for which this condition will satisfy. Now let's put n is equal to 1. You get omega t is equal to pi plus omega t plus pi/6. This will cancel out. And so this is actually useless. N is equal to 1 does not exist. There's no solution. N is equal to, this is a, wait, N is equal to 0, sorry. N is equal to 0, omega t is omega t plus pi/6. So this is gone. This doesn't make sense. Put n is equal to 1, omega t is pi minus omega t minus pi/6. We get 2 omega t is 5 pi/6. Did I get pi/3 or pi? Oh, sorry, pi/3 क्या? Two pi/3. So time will be pi/3 omega. Omega is 2 pi by capital T. Yeah, T/6, you're right. So this is an acceptable answer. This is the first time they will meet. So exam they can ask you this also, na? Find the third time they meet. Now you should try this again for n is equal to 2. So basically for all even numbers, this thing gets messed up. There's no solution. n is equal to 3, you will get omega t 3 pi minus omega t plus pi by 3. This is valid the second time. N is equal to 4 is again gone. N is equal to 5 is third time. So this is nice because you'll get multiple answers. Clear? Have a look at this. The question is still not over. Find the maximum distance between them. How will you do
So,
that?
Can you
How
write
about-
the cos wala also, like omega, the angle wala thing for the cos function?
What you're talking?
But like how sine is n pi plus the general solution for the angle, like cos alpha equal to cos x.
Check it out, na trigonometric equations. Max में जाके करो ना boss. Why are you asking me? You should
Sorry, sir,
remember that.
I forgot.
Go and
it.
revise. You can forget. I can't forget. Yeah, I तो don't remember only. मुझे सिर्फ साइन याद है. I hate cos. I'm a sine person. Clear with this? Get the second part. I'll give you a minute. What is the maximum distance between these two then? Don't try to use max here. Try to visualize in the circle. That will be more easy for this part. And you get a standard result. And you need to mug up the result. Exam, you won't have time to derive that one. Listen, general solution. Let's try to understand what does it mean by maximum distance. Let's say x1 is a sine omega t. And let's say x2 is a sine omega t plus 5. That means when these two particles are motion is starting, the one guy is starting from here. The second guy is starting somewhere here with an angle 5. At this point, if I ask you to find the distance between them, what will be the distance between them? So 1 ka shadow is this, 2 ka shadow is this. This is the distance. Now, after some time t, when they move, remember, don't forget both have same omega. That means the angle between them will remain same. After some time t, the red guy will come somewhere here. The green guy will come somewhere here. And this angle will still remain phi. Now, if you drop the perpendicular, this is the shadow. This is the shadow. Now the distance between them is this. Now, if you keep doing this, you will observe. Can you tell me when will you get maximum? You will get maximum when both of them are exactly on either side of the vertical. If one is here and 2 is here, exactly symmetrically, 5 by 2 and 5 by 2, isn't this the maximum distance you can get? Because always whatever is this length, uska projection hai na? This possibility, or when you're here and when you're here, again same thing, angle is 5 by 2 and angle is 5 by 2. This is the maximum you can get. So max distance occurs when both the particles are exactly, on either side of the vertical line. When particles are on either side of y-axis. So from here you can get a general formula. Max distance is 2a sine phi by 2, the opposite side, na? Where phi is nothing but the phase angle, phi 1 minus phi 2. In this case, one is 0 and one is this. This is a result which you need to definitely mug up. Is this making sense? So if you drop a triangle like this, so this length will be a sine pi by 2. This length will be a sine pi by 2. So this is the more general result I gave you. So you can take any phase angle and finish it off. If I write this as sine omega t plus phi 1 and sine omega t plus phi 2. There's no need like one has to be 0. You can have both, like let's say one is 5 pi by 6 and pi by 6, something of that sort. Is this logic making sense? So when the two particles are going in a circle, what you're dropping is the shadows. And if you observe the length of the shadows, the distance between them, you'll get maximum distance when both the particles are on either side. The shadows will have a maximum horizontal distance.
Otherwise, you can just do it by differentiation also, right?
x1 minus x2 करके कर सकते हो. That also works. That also will give you multiple answers. You'll get it. It's just lengthy. मतलब here when you can see and figure it out, why to make it lengthy और कुछ नहीं है logic. Clear, everyone? Next one. Let me show you one more like this where the circle will make your life easy instead of trying to use max. The max one, right, is only useful when you have to find times for third collision, fourth collision, then it will be very useful. The circle method will still give you the time for the first time when they meet. Once you ask for second, third, fourth, fifth time, it becomes very difficult. Let's get this. I hope everyone is getting SHM part now. We didn't even start the main thing. Huh? This is all just based on equations we're playing around today. And this is the most difficult one actually. The springs and all actually you'll get it quite easily. That looks like more like NLM. Most people I saw, they have a problem with this equation part only. So be very thorough with this because the same thing will come in waves. This is, if you see all the thing that we did is more of max oriented. So two particles parallel to x-axis about the origin with the same amplitude, frequency, certain instant they found at distance a by 3 from the origin on opposite sides. Velocities are in the same direction. What is the phase difference between the two? Any answers? Draw the circle, you'll understand. 2a by root 3. Sine inverse आएगा रे कुछ नहीं?
हाँ सर आया पास.
So he's saying both on the either side, meaning one guy is here at a by 3. Both the velocities are in the same direction. So let's say assume, so this guy is here going this way. So this guy is here a by 3. So this guy is also going this way. So you're asking me to find this angle. 2 phi. That is a phase angle between them. If that is phi, this is phi. Sine phi is 1 by 3. Therefore, phase angle between them is 2 phi. 2 times sine inverse 1 by 3. Plus, itna hi karna tha. Just take magnitudes, na Arjun? Why to take minus and all that thing? It is just the angle between them.
But it'll come out to be the same only.
हाँ, सेम ओनली. मुझे इतना मैथ्स नहीं आता है बॉस. So you have to simplify and tell me the answer.
Okay.
Anika, you got something else weird. Hope you didn't do something like max people do. Sine inverse 1 by 3 plus sine inverse 1 by 3. They read sine inverse 2 by 3. Medical people do such kind of stuff. They're scary people. मेडिकल स्टूडेंट्स आर एक्चुअली स्कैरी बंच. मुंबई में फिर भी ठीक है, आंध्रा में, हैदराबाद में तो मेडिकल पीपल आर द वर्स्ट काइंड ऑफ स्टूडेंट्स यू कैन टीच. We had a batch when I was in Hyderabad ना 2012 का टाइम में था. Ours was in IIT का एडवांस का हॉस्टल. So medical people had some problem, so they came to stay in our hostel for a few weeks. उनका हॉस्टल कुछ renovation चल रहा था. So they used to stay in the first, second floor. All IITians used to stay in the third, fourth, fifth floor, and sixth floor is the classrooms. It's like a proper jail. So कुछ नया मूवी रिलीज हुआ था, तो IITians went and asked, सर हमारा फेवरेट हीरो का मूवी है, हमको जाना है एग्जाम एंड ऑल. सर कुछ एग्जाम है, मूवी नहीं, कुछ नहीं. द डीन गेव राइट एंड लेफ्ट. एवरीवन चुपचाप चला गया. सर ठीक है यार, एग्जाम दे देंगे, नेक्स्ट वीक प्लान करते हैं, 1 वीक के बाद जाएंगे. मेडिकल पीपल वेंट एंड डस्ट सेम थिंग. डीन सेड कुछ नहीं, क्या बोल रहे हो एंड ऑल एवरीथिंग. That day night around 10 o'clock, these people right in the first floor, they broke the windows. Used to have grills like a jail ka thing. So all of them kicked it and they broke it. So this thing fell down on the ground. It became a ladder. Almost 52 students ran away from the hostel. ना एक गए तो कंप्लेंट है, पूरा क्लास गया तो क्या करेंगे. इनका कॉन्सेप्ट वो था. They went to the movie, they came back at night 2 o'clock, they put that thing back. Kidding it, how we came to know afternoon it fell down again. Watchman saw and he was confused. ये क्यों गिर गया? When they inquired, they came to know these people ran away in the night. The dean got angry. He called all of them. He said, "Kuch to." So he said, normally every Sunday, medical people get a holiday. He said, next Sunday, there is no holiday. We are canceling it out. These medical people got pissed off. On Sunday, they didn't get a holiday. They went to the third floor, fourth floor. They started throwing stones on the road. And नीचे कुछ बड़ा marriage का procession चल रहा था. The stone went and hit the bride or the bridegroom, someone. Those people got pissed off. They entered the hostel and started beating every kid who is there. And who are there in the first floor and second floor? IITians are sitting and studying. These people ran away to fourth and fifth floor and locked themselves. And this marriage ka procession entered and started beating everyone right and left. Then later on, some hostel ka warden, wo ye sab log jaake, and they stopped them. Bada mess tha wo. They were supposed to beat a teacher also. Students protected them actually. He was an old teacher, Max ka, 60, 70 hoga. They put him in the lift and they sent him to the sixth floor. Sir, ab bahar mata ho karke. Students got beaten right and left. Medical students इतना hopeless था. Then we all, medical JEE का people went and complained. Sir, either we stay or the medical students stay. We threw them away that night. We said, यार उनको कहीं पे लेके जाना ना, put them in the railway station. We don't care. We don't want them in the hostel. Very bad experiences. Hopeless bunch था वो. Last one for the day. Who throws stones on a marriage procession, right? Just because you didn't get a Sunday holiday. X is equal to A sin omega t. Find the average speed in time 2t by 3. Easy one. I can ask you multiple things here. Average speed, average acceleration, average velocity. But you got the idea. Did you observe one thing? I gave you the equation. Means I indirectly told you where is the particle starting from. Phi is 0. Means you know where it is starting from. So find the average speed in 2t by 3. 15a/40 इतना अच्छा number नहीं आएगा god. See now, look at the motion here. You're starting where? X is equal to 0. You said 2t/3.
Oh yeah, sorry.
2t/3, where will you be? You can actually calculate the phase angle is how much? Omega into time, na? So that is 2pi/t into 2t/3. Actually, I can just calculate this. So this is time t is 0. 2t/3 can be divided into how much? t/4. I can write 2t/3 as t/2 plus t/6. Agreed? Means you have gone from here to here and then even t/6. Or you can take omega theta is, omega into t and get the angle from there. Means you traveled a, then you traveled a, and in t/6 you travel a/2. No, √3 a/2. Is that making sense? This is the time till t/4. This is the time till t/2. Or if you don't like this, you can say phi is equal to omega t, which is 2 pi by capital T into 2t/3. That's 4pi/3. That's almost how much? 240 degrees. So that's 180 plus 60, isn't it? Means you have reached x is equal to minus √3a/2. Okay, now what is average speed? Total distance by time. That will be a plus √3a/2 plus 2t/3. Okay? If I ask you average velocity, what will you do?
We take the displacement.
Displacement line.
Displacement लेना है. कितना लेना है? Minus sign आएगा. Don't
Minus
forget that.
√3a/2.
ये average velocity है. Average acceleration कितना लेंगे? V final minus V initial by time. We find the velocities and finish it off. So there we can play around like that. Okay? So that is one. So next class when we catch up, we are going to do something called phasors. Quite an important thing. That will come in waves, that will come in alternating current, that will come in wave optics. 3 more chapters. Quite a useful